All right, so let's go ahead and get started. Welcome back to part 3 of our modernization mini-series. Today we're going to be super focused on one of the really important aspects of a modern control system, and that is intelligent devices. So we'll take some time to build out exactly what we mean by intelligent devices, but essentially, you can think of an intelligent device as something that is Ethernet enabled, is self-aware, and can feed directly into a modern control asset like ControlLogix or CompactLogix PLC. Our focus today is really going to be about continuing to drive risk out of your control system, and we'll speak to some of the advantages of leveraging this technology. We will dig a little bit deeper into what each one of these intelligent devices are capable of and what they can provide from an automated diagnostics perspective, as well as increased productivity perspective in part 4 and part 5. So make sure if those details are important to you that you want to tune into those last two webinars as well. So if you missed our first 2 sessions, please go back and register or watch the recordings. Again, these webinars are really intended to stack on top of one another. So we will be covering the intelligent devices portion here today. And in the next 2 weeks, we'll then wrap up with actionable information as well as increased productivity. Just as a reminder, from a format perspective, we're going to cover content in about 20 to 30 minutes here this morning, and then we will open it up for Q&A. If you do have questions in the middle of the presentation, if you'd like to chat them in, we'll do our best to answer those as they come in. So without further ado, let's jump into intelligent devices. Like in other sessions or in our previous 2 sessions, I think this is a good reminder as to what we're trying to accomplish with a modern control system, and that is to take advantage of the value of a truly connected enterprise. So when an enterprise is connected, we're getting very valuable information off of the plant floor, transforming that into actionable information, and leveraging those analytics at a headquarters perspective to ensure that the right decisions are being made in the right locations across your entire manufacturing operations. So when we do that, what we can do is drive better value, lower cost of produced goods, and in turn, turn that value to your end customers. Again, just as a reminder, and we talk throughout this series about smart connected systems. And what we mean by that is essentially these 6 core components of a smart connected system. Now, highlighted in yellow is really one of the foundational items, and this is where we're going to be really focused today is on intelligent or smart devices. But as you can see, smart devices are really surrounded by a mix of different topics and components made up of integrated control and information, scalable computing technology that can be on the edge or even on-prem or in the cloud. And we have the ability to extend applications to mobile devices and visualize information at the right place and at the right time. And we do that by securing the network and getting connectivity through and to all of the end devices that exist in a control system. And finally, the value of doing all of this work and what we're highlighting over these 5 different webinars is some of the extended capability of a smart connected system, and that is better information management and more useful analytics as to what's happening in your control system. And today, as we speak to intelligent devices, In previous sessions, we've talked about reducing risk, enabling that greater connectivity, providing. In future sessions, we'll speak to some of the automated diagnostics and the ability to drive productivity, but with the right plan in place, each one of these outcomes can be achieved. And going back to the overall goal of this webinar series, and that is to really provide insights into how to achieve each of these. So today we're going to be focused again on reducing risk and providing flexibility in the control system. So similar to the first session, if we think a little bit about what assets exist in a control system today, it's very likely that there's a mix of new hardware, there's probably some aging hardware, and even it's very likely that there is going to be some what we would call legacy type hardware. And the challenge with legacy hardware is that because it's legacy, it really was not designed to be connected to easily. It's more likely that it's hardwired versus connected to over a simple Ethernet connection. So what we can do to help you is come in and do a install base evaluation. And what we do through this process is capture information about what assets exist on your plant floor today, maybe even capture what assets exist in your storeroom, provide insights into the risk associated with that current install base based on its product availability, its life cycle state, and then help you plan for and prioritize what assets should be updated based on what level of risk they are adding to your manufacturing environment. So we would highly recommend getting engaged with your local distributor partner. They have the ability to execute this locally. And when you reach out, just be sure to reference an install base evaluation. And this is typically done by the number of panels that will be counted. We've got the intelligent devices session, split into three different kind of primary functional areas. The first one that we're going to dig into is our smart sensor capability and product portfolio. So if we think about sensors and what their function is, right, they are kind of the primary means of capturing what is happening within the control system. And what's happening is that information is being used to determine what should happen next. So from a simplicity perspective, as you can see on this slide, in black font, we have more of the traditional type of sensors. So these are hardwired sensors. They will, maybe there's a mix of different protocols. Some are hardwired. Some people may be leveraging technology like IO-Link. Where we're going to really dig into here in the next couple of slides and keep it high level will be on our Ethernet IP enabled switches, Ethernet IP enabled smart sensors. So in this case, the benefit of leveraging an Ethernet IP enabled sensor is that from a setup perspective, we have add-on profiles that can be easily manipulated in Studio 5000. And what that ultimately means to you is greater visibility and information that is automatically populated in Studio 5000 for you then to make easier control programming choices based on what's happening in a given state. So the first product I'd like to talk about is the Swift-E Reconfigurable 3D sensor. This is a really interesting technology for flexible manufacturing type applications. And what it is it's a It's a sensor array that is made up of 64 configurable virtual sensors. Combined with those virtual sensors are 255 different templates. So essentially, a single product can replace the job of, or do the job of, thousands of photo eyes. And this configurable sensor can change state or change its and its intended use can be changed very quickly from model to model. In addition to that, we have pre-developed faceplates that are available for our HMI content, and we have the ability to directly integrate this technology into our compact and ControlLogix family of processors. So one of the values of this reconfigurable virtual sensor array is that it provides a very simple and flexible mechanism for measuring the height or distance of multiple objects. So imagine if you had a tray that had, in this example, 9 different products that were filling 9 slots in a given manufacturing process. And what you could do with this single sensor is very quickly identify if product is missing or if it's been misplaced. You may even be able to, in another use case example, identify the fullness of a given bin. You could quickly identify or validate how full something is, and quickly provide rough measurements as to the expected height for a given product. So in addition to the SwiftE reconfigurable sensor, another one of our Ethernet IP enabled technologies is a newer product offering, and this is the the bulletin number is 48CR, but it is a Ethernet IP enabled code reader. What's really unique about this code reader is that we have the ability to read essentially any barcode or QR code format. We've got a list of the different types of QR codes that can be scanned, or barcodes that can be scanned there on the right. But the benefit of leveraging this, because it's an Ethernet IP enabled product, is that we can configure this product directly in Studio 5000. And in addition to that, there is an alternative for configuration, and that is a Web Connect utility. But this really small form factor is highly flexible and works well in challenging environments. So those were just a couple of products that fit into that smart sensor field, if you will, from an intelligent device perspective. I'd like to shift gears here and speak to our smart safety portfolio. So smart safety devices, very similar to, or safety devices are very similar to sensors in that traditionally a lot of those products have been hardwired. And when you hardwire safety devices, can be time consuming. It can also drive additional cost into the system, consume a significant amount of panel space. So our smart device portfolio is intended to really streamline the integration experience as well as the configuration experience and reduce the overall wiring and installation costs, because each of these assets only require power and an Ethernet IP connection to be managed and configured. So we're going to speak to a handful of these products here on the bottom right of the screen. First product I'd really like to dig into is the SIP Safety Light Curtain. Traditionally, in the past, we have had to apply different light curtains based on applications. And traditionally, those have been paired with other types of safety mechanisms to be able to meet different safety PLX ratings. So what we've done is we've enabled through an Ethernet connection and leveraging SIP safety, which we've talked about in a previous section or session in session 2 of the Modernization mini-series. But we're leveraging our 450L light curtains. We're adding a SIP safety plugin module, and then that plugin module gets connected to an on-machine format that allows you to define the receiver and transmitter. So the configuration of this product is extremely simple. It's all managed through an add-on profile in Studio 5000. Through this design, we're able to reduce system costs. We're going to reduce the overall time it takes to wire the safety circuit. And because of that, it's going to result in increased flexibility and modularity of system design for and as well as for safety zoning. We're also extending our safe zone scanner solution by adding a SIP safety enabled safe zone scanner. So this will be the Safe Zone 3. And this new generation of safety laser scanner features high definition distance measurement. We also are able to rapidly configure this product through Premiere integration in Studio 5000. In addition to that, we've got pre-developed faceplates that can be used in our view solutions. And what's really unique about this SIP safety enabled safe zone scanner is that we can configure up to 8 different fields and leverage up to 8 different monitoring cases with simultaneous monitoring of 4 different zones. So really compact, robust, and highly configurable safety zone scanner. This can be used in a variety of ways in safety applications today. And then finally, I'll speak a little bit to the addition of our encoder family, with the expansion of that family being the SIP Safety Encoder. So a SIP Safety Encoder can be used in a variety of ways. So imagine, for example, you have an existing PowerFlex variable frequency drive controlling a motor, and you want to ensure or add a capability like monitoring that motor is moving in a safe direction when access is requested through an access door. So instead of going and locking out an entire machine and powering that portion of the machine down, we can leverage SIP safety and combine that with safety tasks in our controller to then increase the flexibility of troubleshooting a machine, ensure that the folks interacting with that machine will be in a safe environment, and then therefore drive risk out of a safety application, as well as provide greater flexibility as to how users interact with machines. So that's just one example. There's a variety of ways that this can be used, but please reach out to our team if you'd like some other examples. So from the first 2 topics, we've covered smart sensors and our smart safety portfolio. We're going to bring home the intelligent devices session with a little bit more detail about our smart motor control architecture. One of the things that we do extremely well is control the speed of motor protection devices, as well as the speed of just fixed speed, variable speed, and motion control assets all over Ethernet IP today. So in this first couple of slides, we're going to speak to some of the changes that have recently come about for our fixed speed motor control protection devices. And the first one we'll talk about here is the E1 Plus which is now considered uh, an aging asset, and I believe it's moved into end of life status. So this product is going to be replaced formally by the E100 electronic overlay. What's great about this product specifically is that we have much greater accuracy and repeatability. So we're using current measurement-based protection. We're leveraging electronic design with thermal memory, and that design is put into a very rugged construction. So we've got a wide range of current adjustment, and we have a couple of different direct mount options for IEC and NEMA type starters that this can be connected to directly. And then finally, from a versatility and expandability perspective, we've got an option to have or leverage a pass-through design. We've got a variety of adjustable trip classes and reset modes. Can also provide ground faults and jam protection, as well as external CT configurations. So the E1 Plus again will be replaced by the E100. Hopefully you see here why this is a good investment to make as a formal replacement. And that leads us to the more advanced motor protection overload relay, and that is the E100. The reason it's more advanced is because this is an Ethernet enabled protection device, and because it's Ethernet enabled, we're able to generate some really interesting and useful analytics and tags directly in Studio 5000 to better manage this asset. So since it's on Ethernet IP, I mentioned some of those advanced diagnostics, and those motor type diagnostics include percent thermal capacity, time to trip, total energy utilization. So you can use those types of information that exist in this device today to better control your manufacturing process and use that to reduce troubleshooting and unplanned downtime. So moving into our smart motion control offering, we've recently rounded out the bottom end of our motion control portfolio. So in the past, you may have seen or leveraged a handful of different older motion control technologies. Those technologies are being replaced by the Kinetics 5100 and the Kinetics 5300. So now you can see we have 4 different Kinetics 5000 products that range from very simple standalone machines that are single axis or low axis count. They have hardwired safety, and they're configured with their own separate programming environment, whereas the K5300 through the K5700 are all SIP motion drives. So those drives speak directly to Logix controllers and are configured through Studio 5000. So this range, these 3 different drives really provide kind of a tiered type approach to motion control specifically. So with the K5300, we're looking at simple, small to medium-sized machines. We would still have to use hardwired safety. When you move up to the Kinetics 5500, you're looking at still lower axis counts, but we have the ability to support network-based safety and also combine that with a shared DC bus, so we can really simplify the in-panel wiring for these assets. And then finally, the K5700 is really our high-performance architecture-based drive. This is for high axis counts. We have single and dual axis modules here, but both hardwired and network safety type options, but then can really extend the safety experience by leveraging advanced safety options in Studio 5000 when compared with a guard Logix controller. What we want to show here, since we're talking about modernization, is if you have been using any of the products on the left, the Kinetics 300, Ultra 3000, the K350, and or the Kinetics 2000, those devices are all entering later lifecycle statuses. So the first three are all end of life today and will be discontinued at the end of 2022. So we have about 18 months between today and last time buy for those specific devices. So now is the time to start planning and being proactive with what a migration to a new platform looks like. Any one of our motion specialists would be willing to jump in, help you, and also identify and figure out if there's an opportunity to optimize the motors and the size of the motors that are controlling specific applications. So please reach out to our team for more detail about what the right choice would be, but just know that there's a direct migration path or modernization path for every one of these legacy assets today. Here's a really good example of the way that Kinetics, the bottom end of that Kinetics family, could be used. So there's two different ways to look at this application. There's our entry-level component class type solution, which is made up of a Micro 800 PLC and a PanelView 800 and a Kinetics 5100. So the Kinetics 5100 is not SIP motion, so we have pre-developed user-defined functions that can be added to a Micro 800 to easily control a Kinetics 5100 solution. Whereas on the right, highlighted in red, we could combine or leverage either a Kinetics 5100 with a compact Logix controller or a Kinetics 5300 SIP motion drive and tidy up the the amount of panel space required, since the 5100 is non-zero stacking, whereas the Kinetics 5300 is a zero stack rated drive. One program that your team could take advantage of would be our power control team has made available a modernization program specifically for VFDs. So if you reach out to and work with your distributor specialist team, they would be able to provide detail about what is all comprised of or is encapsulated in this program specifically. And today we spoke to a variety of different smart devices, intelligent devices. We talked about smart sensors. We then spoke to smart safety devices, and then brought home the messaging today with our smart motor control portfolio. So hopefully, again, this was insightful and useful information. We're going to open it up to questions. Stay tuned next week for what we think will be two of the really impactful sessions and a great way to wrap up our modernization mini-series.